Hello friends, today in this video I'm going to discuss about sum of series. Hello guys, welcome back to my channel. Today we are going to start with the part 3 of sum of series. We are going to do some programs based on nth term. So let's start. Let's start with the first program. Now, the first program I have taken a similar one like we have done for n, so that you understand the difference. Now, over here the program is s equals to 1 plus 2 plus 3 till the nth term. Now, the first thing I have told you, whenever we are using nth term, we don't see what the sum of series is about. So, we fill up the loop like this for every nth term program. So, I equals to 1, I is less than equals to n, I plus plus. So, this is the first job we are going to do whenever we are dealing with the programs related with nth term. So that we have to keep in mind. Now after filling up this, we will check the program and if we will try to see if it matches with the loop. If there is a match, we can use I. If there is no match, we have to use some other variable. Now let's have a look. I will become 1, then it will become 2, then 3, then 4, so on. Is it matching with the program given? 1 plus 2 plus 3, if you see there is a match, because I is 1, then 2, then 3, then last I will become n. So there is a match. So we can use I for this program, but not for all the programs. So here we can write s equals to s plus, because we have the plus sign everywhere, and we can simply write I. So if you notice, this program and the program done with n as the ending point is same, but it's not going to be same for every case. So for this one, it's becoming same. So after this, we just display sum of series equals to s, where the value of sum of series is stored in the variable s. So that we have to keep in mind. Now when we do some other programs, there will be a lot of changes over here. So you have to be ready for that. Now we'll do the second program. Now look at the second program over here. We have got s equals to 1 into 3 into. So the first change over here is we are using multiplication. And we have nth term. So if we have nth term, you know how to frame the loop. Before that, few things I just discussed. We are taking variables like I for the loop, n to take the value from the user, s we have declared it as 1. Now some of you may be thinking, why s over here is 1? Because we are using multiplication. And if you put 0 over there, 0 into any number is 0. So for multiplication, we have to put the value of s as 1. And I have taken one more variable. We will discuss about that later. Over here we are taking the value from the user. Now framing the loop, whenever it's nth term, it will be I equals to 1, I is less than equals to n, I plus plus. So this is the first thing that we are supposed to do over here. Now after that, we'll check the loop with the series. If there is a match, we are going to use I. Otherwise, I have already told you we are going to use some other variable. So over here we have I equals to 1. Then it will be 2, 3. So let's check 1. There is a match, 2. 3. So we don't have a match after that. So we are not supposed to use I whenever we are calculating the sum of series over here. So we are supposed to use something else. So for that, I have used a variable p. Now what will be the starting point, the first value of p? So for that, we have to refer to the series. What is the first number we have? We have 1. So p, we have to set it as 1. So the first thing we are setting p as 1. And the sum of series will be s into, I hope you understood why multiplication, because we are multiplying all the numbers, and s into p, because the number over here is going to be p. But the work is not done right now. We have to do something more. So what is that? We have to find out what is the interval over here. So from 1 to 3, we have to add 2. 3 to 5, we have to add 2. So every time the value of p has to increment by 2. So that has to be done inside the loop. So inside the loop only, what we will do, we will write p equals to p plus 2. So if you write this, what happens? Every time the value of p gets multiplied by s, the next thing it gets incremented by 2. So the loop is working on its own. It's working like 1, 2, 3. But the value of p is changing 1, 3, 5, which is required. So this is the difference between n and nth term. So I hope you have understood the difference as well as how to do the programs related to nth term. And after the loop is over, simply we display the sum of series. So this is how we do the second program. The third program over here, we have got a fraction and we have got nth term. So few things like the data type over here will be double and the value of s will be 0.0. As we know it's nth term, the loop is very simple. We have to write I equals to 1, I is less than equals to n, I plus plus. So this is how we set the loop. After that, what we do, we try to match it with the pattern. So over here we have got numerator and denominator. So we'll try with both. We'll try with numerator as well as denominator. If there is a match, we can use I. Otherwise, we have to use different variables. In some programs, you may need to declare 2 different variables, 3 different variables. So the number of variables you can use is unlimited. So you can use any number of variables. You can do that. So first thing, we'll just check whether we have a match, because we know I is 1, 2, 3, 4. So if you look at the numerator, we have 1, 2, 3. So if you look at I and the numerator, there is a match. So for the numerator, we can use I. And if you look at the denominator, 1, 2. So first only there is no match. So we cannot use it for the denominator. So what we'll do for denominator, we will use a different variable. So different variable P. The starting point of P is 2, so we'll set P as 2 over here. And then we'll move on to the sum of series. So S equals to S plus, you know why it is plus? Because everywhere we have got the plus sign. As we know there is a fraction, we'll put it inside the bracket so that it's very simple for us to understand. And inside the bracket, numerator, we have already checked, numerator is I, because I becomes 1, 2, 3 till n. Now we also got 1, 2, 3. So we can simply write I divided by, now for the denominator we have taken a new variable called P. So directly we will place P in the denominator. So this is the end of the line. So this way we calculate the sum of series. But the complete work is not done, because the value of P has to increment. So it has to increment by, from 2 to 3 we have got 1, 3 to 4, 1. So it is incrementing by 1. So simply what we can do, we can write P plus plus. So this way we are supposed to do the program. Now some of you maybe you have done the program differently. So I'll show you the second method also, where you can use a little bit of logic, more logic in it, and you can do the program without using the variable P. So we can do that also. So how will we do that? Let's have a look. If we look at the numerator, we know it's I. The denominator in terms of I, if you want to write the denominator in terms of I, how will you write it? Now if I is 1, how will I become 2? So suppose I equals to 1. So what will be the value of I plus 1? I plus 1 will be 2. Similarly, if the value is 2, the value of I is 2, then I plus 1 is how much? 3. So what we can do is, we'll just remove this. We don't use this P. Suppose we are not using this also. And over here, what we can do is, if the numerator is I, denominator is I plus 1. So we can write down over here, inside the bracket, I plus 1. And we close the second bracket. Now some of you may be thinking, why are you putting I plus 1 inside the bracket? Now, one rule you have to understand, whenever there is a fraction and in the numerator or denominator there is more than one value or variables, you have to put it inside the bracket. Because over here, in order of operation, if you go through the order of operation, if you don't put the bracket, I will be divided by I first and then it will be added by 1, which will be wrong. So that's why first I plus 1 has to be added, then the division has to take place. So this program can be done in various ways and I have shown you 2 of them. Now, after everything is done, at the end we know we display the sum of series. So this is how we do the third program. So you can use any method, both the methods are correct, whichever is suitable for you, use that. The fourth and the last program over here, it's a little bit tricky. But even then, I want you all to try. By now I think you have understood so many things, so I want you all to pause the video for a moment and try this program yourself first, and then later on we can compare it with the program I do. So please do that. Okay. Now moving on, if you look at the pattern, we have a numerator, denominator, we have got nth term. So first things first, so let's use the nth term technique to frame the loop. So this will be I equals to 1, I is less than equals to n, I plus plus. So this is how we frame the loop, and we know we are supposed to compare. So if you are comparing, first we have numerator and then we have denominator. First thing, we don't have anything over here. So I hope you know, if you don't have anything in the denominator, we can write down divided by 1. So that thing we know. That's very simple. So let's check. You know, it will become 1, 2, 3. So let's check with the numerator. We have 1, it's a match. 2 and 3, there is no match. So we cannot use I for the numerator. Now moving on to the denominator, we have got 1, then we have got 4, 9. So let's check. 1, there is a match. 2, there is no match. So in the denominator also, for the moment, we will assume we cannot use I. Now let's see how to work. The numerator, it's very simple. From 1 to 3, 3 to 5, it is incrementing by 2 every time. So we can take a variable like p. So we can take p as 1. So we can take p as 1 for the numerator. For the denominator, let's have a look. We have got 1, then 4. So increment by 3. Then from 4 to 9, we have got increment of 5. And from 9 to 16, if you see, we have to increment it by 7. So the increment is not the same. So we have to get the solution for this one. So if you look at the pattern of this sum of series properly and carefully, we can notice 1, 4, 9, 6 as 1 square, as 2 square, as 3 square, as 4 square. So basically, the denominator is the square of the number 1 square, then 2 square. So we have to frame the question, means we have to change the position in this way. Now it becomes a little bit logical. Now if you take only the base value, the power is always 2. So we will leave the power. Power is always 2, so we will leave the power. So whatever is changing, 1, 2, 3. So we will try to compare it with I again. Now see, there will be a match because I is 1, then 2, then 3. So basically the denominator is the square of I. So we know that. Now we are going to use that technique over here. So S equals to S plus, we know why this plus, because there is a plus sign. And again we'll open a bracket because we have got fraction over here. For the numerator we have taken the variable p. So we'll write down p divided by math.power. I have already discussed about math.power in the previous program. If you don't know what is math.power, you can just go to that part and you can just check it once. Basically, math.power means to generate the power. We have the base and the power, we generate the value. So we have math.power. The base 1, 2, 3 is I. So I, comma, and the power is 2. So it's always 2. So we'll write down 2.0. Now some of you may be thinking why I am writing 0.0. Now math.power is a function, mathematical function, which returns a double type value. So that's why 2 also we have to make it double. So that's why I am writing 2.0. So this way we are getting the value of math.power. After that we close the bracket. We close the bracket of the numerator and denominator. And after this, now we have to worry about the numerator because the denominator thing will be worked out over here. Every time I will become 1, 1 square will be 1. Then I becomes 2, 2 square will be 4. Then I becomes 3. So using this function only, the values will be generated for the denominator. For the numerator, the value of p is incrementing by 2 every time. So we have to write p equals to p plus 2. Now every time the value of p is taken over here as 1 first, then it becomes 3. 3 is taken, then it will become 5. So this way we get the numerator as well as the denominator. And after the loop is over, simply again we will display the sum of series. So I hope you have understood what is the difference first of all between n and nth term and how to solve the program when we have nth term given in the question. Thank you guys for watching my video. I hope you liked it. If you have any doubts, any queries regarding anything, you can just mention that in the comment section given below and I'll get back to you. The programs written over here are not complete. So if you want to download the complete program, you can just download it from the link mentioned in the description. Very soon I'll be coming up with part 4 of sum of series, where we are going to discuss the sum of series when the ending point is a number. So till then, stay tuned, stay safe, stay at home. Thank you guys for watching my video. If you like my video, please hit the like button and don't forget to subscribe my channel, Accidental teacher. Now for any reason, if you have to go outside, please don't forget to put this on.